In this video, we're going to be talking about our last factoring techniques. They involve some special patterns here. If you recognize a quadratic that uses a special pattern, it makes life a lot easier. You're either going to save yourself a lot of time or a lot of headache, or both. So I'm going to try and give you tips on how to notice these special quadratics, and then how to do the special factoring patterns that allow you to save a lot of time. Alright, so the first special pattern is called a difference of squares, or a difference of two squares. And they're really easy to spot because there's only two terms in the quadratic. So if you ever see a quadratic with only two terms, chances are it's going to be a difference of squares, and you're going to be allowed to do this special little pattern here. And it's really quick. So let's see what we do. Here we have a difference of squares. We have two terms being subtracted. The first term is a square, the second term is a square. So there's a couple checks you can do. What we do is we set up two sets of parentheses. We ask ourselves, what's the square root of the first term? So the root of first term, so down here, the root is x, right? The second part is the root of the second term. See if I can fit it here. Second term, a little messy. Just listen to what I'm saying. Root of second term. So what's the root, the square root of the second term? Well, the square root of 16 is 4. What we're going to do is we're going to put both of those in both sets of parentheses. And the sign that goes in each one is actually just a combination of both signs. So the first parenthesis gets a subtraction sign. The second set of parentheses gets an addition sign. And we're pretty much done. We could FOIL to check. X times x is x squared. X times positive 4 is positive 4x. Negative 4 times x is negative 4x. And negative 4 times positive 4 is negative 16. Combine your middle terms and you'll find that they cancel each other out. Positive 4x minus 4x cancels each other out. And that is how we get two terms and a difference of squares, right? We got x squared minus 16. That's what we started with. So if we set each of these parentheses equal to 0, x minus 4 equals 0, well, we get positive 4. Just add 4 to both sides. And we also have the x plus 4 equals 0. So if we subtract 4 from both sides, then we get a value of negative 4. So x has two values, positive 4 and negative 4. You can then substitute those into your x here and make sure you get 0 if you want to check. Alright, so sometimes with the difference of squares, we're going to have to do more than one factoring pattern here. So we're going to have to do what we just did twice sometimes. That's why I like to start, I like to put the negative sign in the first set of parentheses in case we need to do this next step. So let's see what happens here. What are we talking about? So as you can see here, we have another difference of squares. We can take the square root of the first term and the square root of the last term. We're going to put the square root first. So the square root of x to the fourth is actually x squared. So that's the first thing that goes in both sets of parentheses. Take the square root of the last term. That's what goes next in our parentheses. So the square root of 16 is 4. Now here's why I put the negative first. I put the minus in the first set of parentheses because you can see here we have another difference of squares. We can take the square root of the first term again, and we can take the square root of the last term again. So we're going to have to refactor this. This is called a double difference of squares. Let's put that plus there. That's just going to stay the same. We might as well just carry that on over here. We're not going to deal with that because this is not a difference of squares. It has an addition here, so we can't factor it. It's not going to have that special little pattern we just did because of that positive there. The one with the minus, though, we can. We can take the square root of the first term again, x squared. The square root of x squared is x. So we're going to put that in the first spot of each parenthesis. The square root of 4 is 2, so we're going to put that there. Put the minus first, the plus second. And now we have three sets of binomials here. We could FOIL the first two here and get x squared minus 4, right? And then if we multiply that or FOIL that again with the x squared plus 4 that we haven't dealt with, then we will eventually get back to the beginning. X squared times x squared is x to the 4th. Our middle terms are going to cancel. Let's not even deal with the o and the I in FOIL. And let's just do our last terms. X squared, negative 4 times positive 4. That's negative 16. So there we got all the way back to the beginning. So you kind of have to do FOILing twice to check it in a double difference of squares. Also, one thing we're not going to worry about necessarily, as you get more advanced in math, you can set this set of parentheses equal to 0 and solve. But you need to know how to take square roots of negative numbers and use your imaginary numbers. For now, I'm not going to deal with that. You can look at my Algebra 2 videos if you want to get into that. But here we're just doing geometry, so let's just focus on our normal real values here. So we got x minus 2 equals 0. Well, we know it's just positive 2. And x plus 2 equals 0. Solve for x, we get negative 2. So we got positive 2 and negative 2 as possible values of x. We'd also get one imaginary value out of this, but we're not going to deal with that right now. Alright, so that's a difference of squares, or a difference of two squares. We got one more special pattern here. This is called perfect squares. And we use perfect square factoring a lot more in Algebra 2 as well. So again, we're just kind of practicing for the next class. So here's a perfect square pattern. What does it mean to be a perfect square? Ask yourself 3 questions, and if you can answer yes to each of these questions, you are allowed to do the perfect square factoring pattern. So let's start asking the questions. Is the first term a square? Well, is x squared a square? Yeah, we could take the square root of it. What's the square root? Well, the square root is x. So what we do is we place the square root of the first term in the first part of our parentheses down here. Okay, and then we go on to the next question. Is the last term a square? This last term here, 16. 16 is a square, so yes. What's the square root? 4. So we put the square root of the last term, last in our parentheses here. So really all we're missing is a sign, right? Well, if you ask yourself this last question and you answer yes, we're going to be able to put the sign in there. So this is where it kind of gets complicated. We'll break this down a little bit. Is the middle term, this middle term, is it twice the product of the first and last term's roots? So that sounds complicated, so let's break it down. Product means multiply. So what is the product of the first and last term's roots? Well, we wrote the roots right here. It's 1x and 4. So what's their product? 1 times 4 is 4, or sorry, 1x times 4 is 4x. Right? And it says, is the middle term twice that? So we got to double this, multiply it by 2. Well, we get 8x. So without paying attention to the sign, is that the middle term? Yeah. So that allows us to finish our questions for a perfect square. We know we can use this pattern, and we're just missing this middle sign here. Well, it actually comes from the middle term. So whatever sign the middle term has is what we stick in both of these parentheses. So now we have 2 binomials here, and they're the same thing, right? Well, we can rewrite that. If we multiply something by itself, that's a square, right? So we can rewrite it as x minus 4. We just have to write it once and say it's squared. It's multiplied by itself. And so right here, this is where we get the value of x. We could either look at these, but they're the same thing as this. We set it equal to 0, x minus 4. Sorry, x minus 4 equals 0. We'll add 4 to both sides, and we get x is 4. There's only really one answer when it comes to perfect squares because really you're having two sets of parentheses that are the same exact thing. So we could say 4 and 4, but that would be repeating ourselves. So we just say it once. Alright, so let's try one of those again. Slightly complicated process. The more you practice it, the better you'll get at it, the faster you'll get at it. So noticing what a perfect square is not very easy. It kind of looks like all other quadratics. So you basically just have to ask yourself those three questions. And if it's obvious right off the bat, then you don't have to do much work. So let's ask ourselves the questions. What is the root, or is it a square? First of all, is the first term a square? Yes. What is its root? And the square root of x squared is x. So put that there. Is the last term a square, and can we take the square root of it? Well, yeah, 9's a square, and the square root is 3. So we got 3 and x. Those are the roots. Let's multiply them together. We get 3x. And now let's double it. Well, 2 times 3x is 6x. Is that the middle term? Yeah, it is. So we can put the middle term sign in there and rewrite it as a binomial squared. And then solve for x. X plus 3 equals 0. So subtract 3 from both sides, and x is negative 3. So it's a little bit quicker if you were to recognize that this is a perfect square quadratic. But if you didn't notice it, you could just x factor it and you get the same thing. Let's try it. So we put the product of a and c, or a times c, on the bottom. That's just 9. 9 times 1. b goes up top. That's 6. Factors of 9 that add up to 6. Well, 3 times 3 gives us 9, and 3 plus 3 gives us 6. So then we end up writing the exact same thing. X plus 3 times x plus 3. And then solve for x, we get negative 3. So if you don't recognize perfect squares, it's not the end of the world. It just means that you have to either use another factoring method, which is a little slower, or you use the quadratic formula, which is even longer. So really this pattern helps you save a lot of time. Alright, so those are your special factoring patterns. We had difference of squares and perfect squares. Go ahead and practice those, get better at recognizing them, and then you will save yourself a lot of time.